The Milky Way galaxy drifts through the obsidian void, a shimmering spiral composed of 200 billion suns. From the perspective of a human life, or even the entire recorded history of a civilization, this vast collection of matter appears as a fixed and eternal monument, a frozen tapestry of light pinned against the velvet dark. The stars seem to hang in a state of perpetual equilibrium, their positions across the night sky unchanging and reliable, serving as the steady markers by which we have navigated our own world for millennia. Yet this stillness is a grand illusion, a trick of scale played upon the minds of those who reside within its swirling arms. In reality, our entire cosmic home is a singular, majestic vessel caught in the grip of a silent, invisible current that spans the unfathomable depths of space. We are passengers on a journey of such magnitude that the human vocabulary struggles to contain its significance. Beneath the feet of every living creature, behind the glow of every city, and within the heart of every nebula, a relentless momentum carries us forward. We are not merely orbiting the galactic centre, nor are we simply expanding outward with the general flow of the universe. There is a specific directed pull, a gravitational command that compels our galaxy and thousands of its neighbours to migrate across the abyss. This is the Great Flow, a movement so vast that it dwarfs the individual lives of stars and the fleeting existence of planets. The very fabric of the cosmos is not a flat and static stage, but a dynamic and undulating sea, and we are being swept along by a tide that was set in motion long before the first sun ignited. The sensation of this motion is not felt through the inner ear or the balance of the body, but through the patient observations of those who look toward the furthest horizons. It is the realization that the shore we once thought was stationary is actually receding, and that we are being drawn toward a distant, unknown destination. This shore is hidden from our sight, obscured by a thick curtain of our own making. The very disk of the Milky Way, with its dense clouds of gas and its brilliance of 200 billion fires, acts as a shroud. It creates a blind spot in our map of the heavens, a region where the dust and light of our own home prevent us from seeing the titan that beckons us from the dark. This barrier of soot and starfire has long kept us ignorant of the forces that govern our fate, leaving us to drift through the night with no clear view of the harbour we are approaching. Behind this veil of brilliance, something immense resides. It is a gravitational anchor of such potency that its influence is felt across hundreds of millions of light years. This entity does not merely pull on individual stars, it bends the trajectory of entire galaxies, drawing them into its embrace like droplets of water trickling toward a central basin. We find ourselves in the midst of a cosmic watershed, where the topography of space-time itself is slanted toward a singular point of convergence. This is the heart of the Laniakea supercluster, a name that translates from the Hawaiian tongue as immeasurable heaven. It represents the true extent of our gravitational neighbourhood, a vast territory of space where every movement is a response to a central, hidden authority. As we traverse this silent current, we move at a velocity that defies the logic of the terrestrial world. The Milky Way is rushing through the void at a speed of 600 kilometers per second. At this rate, we cover the distance of an entire planet in the blink of an eye, yet the distances involved are so great that the voyage will last for billions of years. We are travelling toward a gravitational titan that dictates the path of every star within our reach, a master of the local universe that remains largely invisible to the naked eye. This motion is a fundamental truth of our existence, a silent fall through the vacuum that connects us to the largest structures ever conceived by the scientific mind. The realization of this motion transforms our understanding of the cosmos from a static map into a living, breathing ocean of movement. We are no longer inhabitants of a fixed point in space, but voyagers on a ship that has been sailing since the dawn of time. The currents that carry us are ancient, born from the uneven distribution of matter in the wake of the first light, 13.8 billion years ago. They are the echoes of a primordial landscape, where the seeds of galaxies were sown in the furrows of a developing universe. Every atom in our bodies, every grain of sand on our shores, and every photon that hits our eyes is part of this grand migration. The eye finds no rest in the void, for the void is not empty. It is filled with the tension of gravity and the stretching of space. Every star we see in the night sky is a fellow traveller in this great silent fall toward the centre of everything. The constellations are not just patterns of light, they are the lights of other ships caught in the same tide, moving with us toward a destination that remains shrouded in mystery. We look out from the deck of our galactic vessel, peering through the gaps in the dust, searching for a glimpse of the shore that awaits us. The journey is long, the path is dictated by the unseen, and the scale is beyond the grasp of a single mind, yet the motion is undeniable. We are falling through the dark, guided by the hand of a titan, toward the heart of an immeasurable heaven. This is the beginning of our journey into the depths of Laniakea, a quest to understand the invisible hand that pulls us through the night and the destination that waits at the end of the current. The dawn of the 20th century inherited a cosmos of elegant, frozen clockwork. To the astronomers of that era, the stars were the ultimate expression of permanence, a silver dust scattered across a dark room that had no beginning and no end. This was the steady-state reality, a provincial peace where the Milky Way was often thought to be the entirety of existence, a lone island in a nameless sea. The idea that the heavens were in a state of violent unidirectional flux was not merely absent, it was heretical to the very definition of the word universe. For thousands of years the human eye had looked upward and seen a firmament, a word rooted in the concept of something firm, fixed, and foundational. In the high, thin air of Flagstaff, Arizona, during the year 1912, a quiet revolution began within the copper dome of the Lowell Observatory. Vesto Slipher, a man of meticulous patience, turned his spectrograph toward the mysterious spiral nebulae that haunted the deep sky. He was not looking for a moving universe, but for the rotation of these ghostly clouds, hoping to find evidence of solar systems in the process of formation. What he found instead was a signature of motion that defied all contemporary logic. As the light from these distant spirals passed through his prisms, it did not align with the expected markers of the chemical elements. The patterns were shifted, pushed toward the longer, redder wavelengths of the electromagnetic spectrum. This phenomenon, known as the redshift, was the first whisper of a cosmic secret. In the language of physics, a redshift occurs when the source of light is moving away from the observer, stretching the waves of light like a receding siren stretches the waves of sound. It revealed that these nebulae were not drifting aimlessly, nor were they bound by the gravity of our own suns. They were receding. Slipher observed velocities that reached hundreds of kilometers per second, speeds that were entirely incompatible with the notion of a static, local collection of stars. By the time he had measured 15 of these spirals, he realized that nearly all were fleeing from us at a pace that suggested they were not part of our world at all. Yet, the reason for this exodus remained locked behind the limitations of his instruments and the prevailing theories of the time. The true scale of this departure was unveiled a decade later atop Mount Wilson, where the 100-inch Hooker telescope stood as the most powerful eye ever turned toward the heavens. Edwin Hubble, working with the data provided by Milton Humason and the mathematical foundations laid by Henrietta Leavitt, began to measure the distances to these fleeing ghosts. He sought out the Cepheid variables, pulsing stars that act as cosmic yardsticks, within the Andromeda Nebula and beyond. In 1924, the walls of the Milky Way finally collapsed. Hubble proved that these spirals were not clouds of gas within our galaxy, but entire island universes themselves, millions of light-years distant. Our home was no longer the sum of the cosmos. It was merely one of many. This discovery was the prelude to the final shattering of the old world. By 1929, Hubble had paired Slipher's redshifts with his own distance measurements, revealing a terrifyingly beautiful law of nature. The further a galaxy was from the Milky Way, the faster it appeared to be rushing away. This was not a simple movement of objects through a stationary room. It was the room itself that was growing. The very fabric of space-time was stretching, expanding in every direction like the surface of an inflating balloon. Every point in the universe was moving away from every other point, and the speed of this expansion was proportional to the distance between them. The provincial peace was gone, replaced by a dynamic, rushing sea of space-time. The universe was no longer a container for matter, but a participant in its history. This revelation transformed every star from a fixed point into a traveller. It meant that the cosmos had a beginning, a moment of infinite density from which all things had been flung outward in a titanic release of energy. But more importantly for the voyagers within the Milky Way, it meant that our motion was not random. We were caught in a dual reality, the global expansion of the universe pushing everything apart, and the local pull of gravity struggling to hold things together. This transition from a fixed firmament to a rushing expanse redefined the human relationship with the night sky. We realized that we were not standing on solid ground, but were adrift in a medium that was itself in motion. The galaxies were not just distant lights. They were massive, complex structures caught in a cosmic wind. As the universe grew, the gaps between these island universes widened, creating a sense of isolation that was balanced only by the discovery of even larger structures that sought to defy this expansion. The sheer scale of this expansion meant that the light reaching our eyes from the most distant reaches of the cosmos was ancient, carrying the news of a universe that had already changed. The light was tired, its energy sapped by the very expansion of the space it traversed, shifting its colour toward the crimson as a testament to the distance it had covered. In this new, restless cosmos, the question of our own movement became paramount. If the universe was expanding everywhere, why did some things seem to move in ways that expansion alone could not explain? The discovery of the expanding universe provided the framework, but it was only the beginning of the story. It established the baseline, the cosmic wind against which all other motions must be measured. We were now ready to look past the general expansion and find the specific haunting currents that suggested something else was out there. We began to sense that we were not just being pushed away by the growth of space, but were also being pulled by a hunger that the expansion could not satisfy. The stage was set for a new kind of mapping, one that did not look for landmarks, but for the invisible tides that governed the flight of galaxies through the ever-growing void. Beyond the horizon of our understanding, a gravitational titan was waiting to be discovered, a force that would reveal that even in an expanding universe, everything is falling toward something. The central plane of the Milky Way is a dense, light-choking thicket of matter, a grand architectural feature of our galaxy that simultaneously provides our cradle and our cage. As we reside within the flattened disk of this spiral city, we are surrounded by a colossal ring of interstellar debris, a mixture of cold gas and microscopic grains of carbon and silicates. This celestial equator acts as a great wall of soot, stretching across the entire 360 degrees of our sky. For the early pioneers of the telescope, this region was not a window but a mirror, a dark, opaque boundary that reflected only the internal contents of our own galaxy, while obliterating everything that lay beyond. They called it the zone of avoidance, a term coined by the astronomer Richard Proctor in the late 19th century, to describe the conspicuous absence of distant nebulae and galaxies along the path of the Milky Way. This belt of darkness was more than just a navigational hazard for star mappers. It was a profound metaphorical barrier to human knowledge. While the north and south galactic poles offered clear views into the depths of the intergalactic void, allowing us to see millions of light years into the distance, the equator of our galaxy remained an impenetrable fog. It was as if we were trying to survey the surrounding landscape from the centre of a dense, smoke-filled forest. We could see the clear sky directly above us and the ground beneath us, but the horizon in every direction was swallowed by the shadows of the trees. This cosmic fog did not merely dim the light of the distant universe, it extinguished it entirely in the visible spectrum. For every billion photons of light that set out from a galaxy on the other side of our disk, perhaps only one would successfully navigate the labyrinth of dust to reach a human eye. The physical nature of this barrier is a testament to the violent and recycled history of our galaxy. The dust is composed of the heavy elements forged in the hearts of ancient suns, scattered into the void by the death throes of supernovae. These grains are tiny, often no larger than a fraction of a micron, yet their collective power to scatter and absorb light is absolute. In the visible wavelengths that our eyes evolve to perceive, this dust is an impenetrable wall. It creates a silhouette of the Milky Way against the background of the universe, a dark rift that carves the sky in two. Because of this, for much of the 20th century, our maps of the local universe were fundamentally flawed. They were maps with a massive jagged hole in the centre, a missing piece of the puzzle that happened to be the very place where the most important gravitational secrets were hidden. This blindness created a state of scientific frustration that lasted for decades. As astronomers began to measure the peculiar velocities of the Milky Way and its neighbours, they realised that we were being drawn toward a specific coordinate in the southern sky. The math was clear. A massive concentration of matter had to exist at that location to exert such a powerful pull. Yet, when they pointed their optical telescopes toward those coordinates, they saw nothing but the thick glittering clouds of our own galactic disk. The gravitational titan was there, its presence felt in the way our galaxy lurched through space, but it remained a ghost, hidden behind the Great Wall of soot. It was a gravitational master whose face we were forbidden to see, a silent director of our destiny that operated from the shadows of the zone of avoidance. The implications of this hidden reality were unsettling. It suggested that the most influential structures in our cosmic neighbourhood could be completely invisible to us simply because of our unfortunate perspective within the Milky Way. We were like sailors on a vast ocean who could feel a powerful current pulling their ship toward a massive whirlpool, yet could see nothing but a thick, impenetrable mist on the horizon. This barrier forced a realization that the visible light we rely on is only a tiny sliver of the information available in the universe. To look through the soot to see the behemoths that were tugging at our sleeves, we would eventually have to learn to see in colours that no human eye had ever perceived. We would have to wait for the development of technology that could detect the long, patient waves of radio and the piercing, high-energy screams of X-rays, which can slip through the gaps in the dust like ghosts through a wall. Until that technological awakening, the zone of avoidance remained a realm of myth and speculation. It was a place where the laws of the universe seemed to operate in secret, away from the prying eyes of the inquisitive. The massive structures lurking there, the clusters of thousands of galaxies, the filaments of dark matter, and the great gravitational wells were known only by their effects, never by their appearance. This era of astronomy was defined by a haunting sense of incompleteness. We knew we were moving, we knew something was pulling us, and we knew exactly where that something was located. Yet the curtain of our own galaxy refused to rise. The Great Wall of Soot stood firm, a monument to the limits of human perception, and a reminder that in the vastness of the cosmos, the most important things are often the ones we cannot see. The Titan was there, heavy and silent, waiting for the moment when our ingenuity would finally pierce the veil and reveal the true architecture of our corner of the universe. The mid-1970s arrived with a new kind of silence in the halls of astronomy, a quiet tension born from the realization that our celestial maps were incomplete. The discovery of the cosmic microwave background radiation, the fading afterglow of the first light in the universe, had provided scientists with something they had never possessed before, a universal frame of reference. This ancient light, cooled by billions of years of cosmic expansion into the microwave spectrum, filled every corner of the sky with a nearly uniform glow. However, as the sensitivity of our instruments improved, a subtle and profound asymmetry emerged. One side of the sky appeared slightly warmer, shifted toward the shorter wavelengths of the blue, while the opposite side appeared slightly cooler, stretched toward the red. This was the cosmic dipole, a signature of absolute motion. It revealed that the Earth, the Sun, and the entire Milky Way were not merely expanding with the fabric of space, they were rushing through it at a staggering velocity of 600 kilometers per second. This discovery sent a shockwave through the scientific community. While the expansion of the universe, the general outward flight of all things, was well understood, this peculiar motion was an anomaly. It was as if a ship on a vast expanding ocean had noticed that it was not just drifting with the current, but was being propelled by some additional hidden force toward a specific point on the horizon. The speed was far too great to be explained by the local gravity of our immediate neighbours, such as the Andromeda Galaxy. Something far larger and more distant was exerting a massive gravitational pull, a hidden titan that was drawing our entire region of the universe toward its heart. This was the first detection of what would become known as the Great Flow, a collective migration of thousands of galaxies across the void. The quest to identify the source of this motion led astronomers back to the very region they had long avoided, the dense, dust-choked plain of the Milky Way. To find the giant, they had to look through the Great Wall of soot that had blinded them for centuries. This required a departure from visible light and an embrace of the invisible spectrum. In the late 1970s and into the 80s, the tools of the trade shifted from optical glass to the vast metallic dishes of radio telescopes and the high-energy detectors of orbiting X-ray observatories. These instruments did not see the world as humans do. They perceived the universe through the long, patient waves of radio and the violent, piercing energy of X-rays, both of which could slip through the gaps in the galactic dust like spirits passing through a solid wall. Radio astronomers began to map the distribution of neutral hydrogen, the most abundant element in the cosmos. By listening for the specific 21-centimeter hum of this gas, they could trace the skeletons of distant galaxies hidden behind the zone of avoidance. Simultaneously, X-ray satellites like the High Energy Astronomy Observatory began to scan the same regions. They were not looking for stars, but for the white-hot gas that congregates in the massive wells of gravity between galaxies. When thousands of galaxies cluster together, the gravity becomes so intense that the gas between them is heated to millions of degrees, causing it to scream in X-rays. These high-energy signatures acted as beacons in the dark, pinpointing the locations of massive concentrations of matter that had never before been seen. As the data trickled in, the missing pieces of the cosmic puzzle began to fall into place. Behind the thickest clouds of the Milky Way, in the direction of the constellation Norma, the instruments revealed a sprawling, dense metropolis of galaxies. This was not a single object, but a massive superstructure, a concentration of mass so great that it defied the standard models of galactic distribution. The mapping efforts revealed that the Milky Way was part of a vast, coherent stream of matter, a river of light and dark matter flowing toward a central point of convergence. The anomalous motion was no longer a mystery. It was the inevitable response of our galaxy to the presence of a gravitational behemoth. The realization that we were caught in this high-speed transit across the void changed the nature of our cosmic perspective. We were no longer observing a distant and detached universe. We were active participants in its grandest movements. The Great Flow was a testament to the fact that gravity is the ultimate architect of the cosmos, capable of organizing matter on scales that span hundreds of millions of light-years. The mapping of the invisible had revealed that the universe is not a chaotic scattering of islands, but a highly structured and interconnected web of filaments and nodes. We had found the source of the pull, a place where the density of matter was so high that it acted as a gravitational drain for everything in its vicinity. This era of discovery was characterized by a sense of profound scale. The more we looked, the more we realized that the Great Attractor was merely the most visible part of a much larger hierarchy. The efforts to peer through the cosmic fog had not only revealed our destination, but had also uncovered the vastness of the journey itself. The Milky Way was travelling through a landscape of unimaginable complexity, guided by forces that had been gathering strength since the dawn of time. The anomalous velocity that had first been detected in the mid-1970s was the heartbeat of our local universe, a rhythmic, directed pulse that showed us exactly where we belonged in the great architecture of the heavens. We were no longer lost in the dust. We were voyagers on a defined path, following the silent command of a titan that had finally begun to step out from the shadows. The mapping of the local universe revealed a structure of such staggering elegance that it required a new vocabulary to describe. Beyond the veil of dust and the local clusters lies the fundamental scaffolding of all that exists, known as the cosmic web. This is not a random scattering of matter, but a vast, interconnected network where galaxies are gathered into long, thin filaments that stretch across the darkness. These filaments are the highways of the universe, composed of both visible matter and the invisible influence of dark matter, acting as the structural bones of the cosmos. Between these threads lie the great voids, hollow, spherical deserts of space where almost nothing exists, spanning tens of millions of light years in diameter. Within this architecture, galaxies are merely droplets of dew, clinging to the silk of a celestial spider's web, caught in the intersections where the filaments meet to form dense clusters and sprawling superclusters. In the year 2014, a team of astronomers led by Brent Tully redefined our understanding of this cosmic geography by identifying the true extent of our gravitational home. They named this structure Laniakea, a term drawn from the indigenous language of the Hawaiian Islands that translates to immeasurable heaven. This name is a fitting tribute to a domain that spans 500 million light-years from end to end, containing the mass of 100 quadrillion suns. Laniakea is not merely a collection of galaxies, it is a gravitational watershed. Just as a mountain range on Earth defines a continental divide, where water on one side flows toward the Atlantic and water on the other side flows toward the Pacific, the boundaries of Laniakea are defined by the direction of cosmic motion. To delineate this immeasurable heaven, scientists mapped the peculiar velocities of over 8,000 galaxies, stripping away the global expansion of the universe to reveal the underlying currents of gravity. They discovered a clear boundary, a cosmic divide where the flow of matter changes direction. On one side of this invisible line, galaxies are being drawn toward the Perseus-Pisces supercluster. On our side of the line, every galaxy, including the Milky Way, is caught in a singular unified current that flows toward a central gravitational well. Laniakea represents the totality of this drainage basin, the entire territory of space where gravity eventually directs all paths toward a common destination. Within these borders, we are part of a coherent whole, a massive empire of stars that moves as one through the expanding void. Our Milky Way is but a small suburb on the distant outskirts of this empire, located along one of the smaller filaments known as the local sheet. From our perspective, the scale of Laniakea is almost impossible to reconcile with the human experience of time or distance. If the entire Milky Way were reduced to the size of a single grain of sand, the Laniakea supercluster would still be a structure the size of a vast city. It contains over 100,000 large galaxies, each teeming with hundreds of billions of stars, yet they are all interconnected by the same gravitational fate. This structure connects us to a larger hierarchy of matter, revealing that our galaxy is not an isolated island, but a participant in a grand, organized movement that spans a significant portion of the observable universe. The architecture of Laniakea is a testament to the power of gravity to create order out of the initial chaos of the early universe. In the first moments after the Big Bang, matter was distributed with nearly perfect uniformity, yet tiny fluctuations in density allowed gravity to begin the long process of sculpting the cosmic web. Over 13.8 billion years, these small seeds grew into the filaments and superclusters we see today. Laniakea is the modern result of that ancient process, a finished masterpiece of gravitational engineering that provides the context for our existence. It is the framework within which all galactic evolution occurs, the stage upon which the life and death of stars play out across the eons. As we look out across the immeasurable heaven, we see that the filaments are not static. They are the channels through which matter continues to accumulate, drawn by the relentless pull of the Great Attractor at the heart of the supercluster. The galaxies are in a state of constant transit, sliding along the cosmic threads toward the centers of mass. This motion defines the life cycle of the supercluster itself, as it slowly contracts and organizes its internal components. Laniakea is a living entity of light and gravity, a colossal organism of stars that pulses with the rhythm of the great flow. Our place within this structure gives us a sense of cosmic belonging, a realization that we are part of a vast, ancient, and profoundly beautiful architecture that stretches far beyond the limits of our own horizon. We are the inhabitants of a celestial watershed, caught in a current that began at the dawn of time and continues to carry us toward the heart of the mystery. The topography of the cosmos is defined by a hidden landscape of slopes and basins, a geometry of attraction that dictates the destiny of every gram of matter. Just as gravity draws a single raindrop down the side of a mountain, eventually channeling it into a stream, then a river, and finally a vast catchment area, so too does the curvature of spacetime direct the flight of galaxies. This is the celestial watershed, a region of space where the very fabric of the vacuum is tilted toward a singular point of convergence. In this grand drainage basin, the Milky Way and its thousands of companions are not merely floating, they are sliding down a gravitational gradient that spans hundreds of millions of light years. This movement is the physical manifestation of a massive imbalance in the distribution of matter, a cosmic valley so deep that it commands the attention of everything within its reach. At the lowest point of this valley lies the Great Attractor, a gravitational titan whose scale is almost impossible to reconcile with our understanding of the local neighbourhood. It is estimated to be tens of thousands of times more massive than the entire Milky Way, a concentration of matter so dense that it serves as the invisible anchor for our entire corner of the universe, while a single galaxy like our own is a majestic assembly of 200 billion suns. It is but a feather in the wind when compared to the weight of this central behemoth. The Great Attractor exerts a pull that overcomes the general expansion of the universe, dragging entire clusters of galaxies toward its heart. It acts as the master of ceremonies for a local symphony of motion, ensuring that the chaotic individual paths of galaxies are woven into a coherent directed flow. The flow begins on the outskirts of the Laniakea supercluster, where the gravitational divide is subtle and the slopes are gentle. Here, galaxies move with a slow, patient dignity, their trajectories barely altered by the distant pull. But as they move closer to the centre, the gradient steepens. The rivers of light that are the galactic filaments begin to narrow and accelerate. The local group, which includes our own Milky Way and the Andromeda Galaxy, is currently caught in one of these accelerating currents. We are rushing toward the centre of the watershed at speeds that exceed 2 million kilometers per hour, a velocity that is not a product of our own engines or the expansion of space, but a direct result of the Great Attractor's relentless hunger. This central point of convergence is not a single object, like a star or a black hole, but a massive region of space where matter has accumulated in extraordinary densities. It is a place where the cosmic web has become knotted and tangled, forming a dense metropolis of galaxies. The sheer mass concentrated here creates a gravitational well so deep that it bends the light of more distant objects, acting as a lens that distorts our view of the far horizon. This anchor provides a semblance of order to the local universe, preventing the galaxies from simply drifting apart into the growing void. It keeps us bound to a larger structure, ensuring that for all the vastness of space, we are never truly alone or without a destination. The scale of the Great Attractor is such that its influence defines the boundaries of our home. Everything within the Laniakea supercluster is, by definition, part of this same drainage system. The thousands of island universes that make up our neighbourhood are all travellers on the same downward path, destined to eventually meet in the dense clusters at the heart of the basin. This realisation shifts our perspective of the night sky. The stars are no longer just distant points of light, but markers of a massive moving fluid. We see the filaments as the banks of a great river, and the voids as the high ground from which the matter has been drained. The universe is not a static arrangement, but a dynamic system of transport, moving matter from the heights of the voids to the depths of the attractors. In this landscape, the Great Attractor is the ultimate arbiter of fate. It is the silent director that has been pulling the strings of galactic motion for billions of years. As the universe continues to expand, the struggle between the outward push of dark energy and the inward pull of this gravitational anchor intensifies. For now, within the borders of Laniakea, the anchor holds firm. It maintains the integrity of our supercluster, keeping the thousands of galaxies in a tight gravitational embrace. We are part of a massive slow-motion collapse, a grand gathering of matter that represents the final stage of structural growth in our region of the cosmos. The Great Attractor is the heart of this process, the heavy, silent engine that drives the great flow and ensures that every star in our sky is moving in harmony with the ancient rhythm of the watershed. We are the water in the river, the dew on the web, and the passengers on a journey toward the deepest point in the immeasurable heaven. The search for the primary engine of this motion leads to a specific coordinate in the southern sky, hidden behind the thickest curtains of the galactic plane. This is the Norma cluster, a sprawling metropolis of stars known in the formal archives as Abel 3627. It sits at the very epicenter of the Great Attractor, serving as the physical heart of the beast that commands our transit. To find this place, astronomers had to look through the Great Wall of Soot with eyes capable of perceiving the invisible. They used the long, patient waves of radio and the piercing, high-energy screams of X-rays to pierce the veil, revealing a concentration of matter so dense that it defies the traditional expectations of galactic distribution. Here, the cosmic web is not merely a thread. It is a massive, tangled knot of thousands of galaxies, all crushed together by their own collective weight. The environment within the Norma cluster is a testament to the sheer power of gravity. In this region of space, the density of galaxies is so high that the void itself seems to groan under the strain of their presence. Spacetime is not merely curved here. It is buckled and warped into a profound gravitational pit. This is the lowest point in our local watershed, a place where the topography of the universe reaches a terrifying steepness. The galaxies that inhabit this cluster are not the pristine solitary spirals found in the quieter suburbs of the cosmos. Instead, they are bruised and battered entities, many of them stripped of their gas and distorted into strange elliptical shapes by the relentless tidal forces of their neighbours. They are the survivors of an eternal series of collisions and mergers, caught in a permanent state of gravitational combat. The intergalactic medium within Norma is not a vacuum, but a sea of incandescent plasma. The gravity of the cluster is so intense that any gas falling into the well is accelerated to incredible speeds, colliding with such force that it is heated to tens of millions of degrees. At these temperatures, the gas does not shine with visible light. It glows with the fierce, invisible energy of X-rays. This hot, diffuse atmosphere acts as a beacon for our instruments, a glowing signature that reveals the true mass of the cluster. By measuring the intensity and temperature of this X-ray light, scientists can calculate the weight of the unseen dark matter that provides the scaffolding for the entire structure. They find that the visible galaxies are merely the tip of the iceberg, a light dusting of snow upon a massive invisible mountain of dark matter that provides the true gravitational muscle of the Great Attractor. The hunt for this source was a decades-long exercise in scientific persistence. For years, the anomalous motion of the Milky Way was a ghost without a body, a pull without a visible source. Astronomers mapped the peculiar velocities of the surrounding galaxies, tracing the lines of the flow back to this single point behind the zone of avoidance. They found that the Norma cluster is not alone. It is the central node in a larger complex of clusters, including the Centaurus and Hydra clusters, which all work in concert to create the massive gravitational field of the Great Attractor. However, Norma remains the most significant concentration of mass in the immediate vicinity, the primary engine that generates the 600 km per second velocity of our own galaxy. As we look toward the heart of the attraction, we see a place of ultimate convergence. It is the destination toward which all the rivers of light in Laniakea are flowing. The Norma cluster is the anchor of our local universe, the heavy, silent master that keeps the cosmic web from unraveling in our region. Its presence ensures that the expansion of the universe is locally defeated, at least for now, as gravity works to pull everything into a single, massive conglomerate. This is the place where the chaos of the early universe is being ground into order, where the filaments of the cosmic web are being woven into a dense, permanent structure. The realization that such a titan exists just behind the dust of our own galaxy is a humbling one. It reminds us that our perspective is limited, and that the most influential forces in our lives can remain hidden for eons. The Norma cluster is a reminder of the hidden architecture of the heavens, a place where the laws of physics are expressed on a scale that dwarfs the imagination. It is the center of the beast, the source of the great flow, and the gravitational master of every star we have ever named. In the silence of the Norma cluster, the universe is being reshaped, star by star and galaxy by galaxy, as the great fall toward the center continues. We are the witnesses to this process, the passengers on a journey toward a destination that was only revealed when we learned to see the light that the dust could not hide. The heart of the attraction is no longer a mystery, but a physical reality, a massive and incandescent anchor in the deep southern dark. The revelation of the Great Attractor was once thought to be the final answer to the mystery of our motion, yet the deeper we peer into the abyss, the more we realise that the universe is a hierarchy of hidden masters. Even as the Norma cluster was identified as the physical heart of our local watershed, a lingering discrepancy remained in the celestial ledger. The peculiar velocity of the Milky Way, that relentless rush of 600 kilometers per second, is too powerful to be explained solely by the mass of the Great Attractor. The math of the cosmos suggests that the Titan we have found is not heavy enough to account for the speed of our fall. There is a phantom pull originating from even further away, a gravitational command that emanates from a region twice as distant as the Norma cluster. This is the Shapley supercluster, the true sovereign of the local cosmos and the ultimate destination of the Great Flow. Existing 650 million light-years from our home, the Shapley supercluster represents the most massive concentration of matter in the observable universe within a radius of nearly 1 billion light-years. It is named after Harlow Shapley, the astronomer who, in the 1930s, first noted a remarkable cloud of galaxies in the constellation of Centaurus. What he saw was the faint glimmer of a structure so immense that it defies the standard definitions of galactic organization. While the Great Attractor is a formidable node in the cosmic web, the Shapley supercluster is a sprawling continent of matter, a dense archipelago of over 25 massive galaxy clusters, each teeming with thousands of individual island universes. It is a place where the density of galaxies is so high that the very concept of a void begins to dissolve, replaced by a continuous glowing tapestry of starfire and dark matter. The influence of this structure extends far beyond its own borders, exerting a pull that spans vast intergalactic distances. We now understand that the Great Attractor is not a stationary destination, but a passenger itself, caught in an even larger tide. The entire Laniakea supercluster, with all its hundreds of thousands of galaxies and its central gravitational anchor, is being drawn toward the Shapley concentration. This reveals a higher order of organization, a hierarchy of attraction where our local Titan is merely a stepping stone in a much larger cosmic journey. We are witnessing a grand, cascading fall. The Milky Way falls toward the Great Attractor, and the Great Attractor falls toward Shapley. It is a cosmic game of Russian dolls, where each structure is nested within the gravitational grip of something even more colossal. The physical reality of the Shapley supercluster is one of extreme density and heat. Within its core, the clusters of galaxies are packed so tightly that their individual identities begin to blur. The intergalactic medium here is even more violently energized than that of the Norma cluster, filled with plasma that has been compressed and heated to temperatures that defy terrestrial comprehension. This region is a massive gravitational pit that has been collecting matter since the first billion years of the universe's existence. It acts as a primary hub of the cosmic web, a central junction where dozens of filaments meet and merge. The sheer volume of baryonic and dark matter concentrated in this single volume of space creates a gravitational potential so deep that it warps the trajectories of galaxies across a significant fraction of the sky. This discovery forces a radical reassessment of our place in the heavens. We once believed we were the centre of all things, then we believed we were part of a lone galaxy, and later a member of a local supercluster. Now we see that we are part of a vast coherent stream of matter that is being funneled toward the Shapley supercluster. This structure represents the ultimate peak of density in our corner of the universe, a monument to the power of gravity to organize matter on the largest possible scales. It is the final harbour of the local current, the place where the great flow that began in the wake of the Big Bang finally finds its master. The Shapley supercluster is the silent architect of our long-term future, the destination that will eventually claim the remnants of our galaxy and everything we have ever known. As we look past the Great Attractor toward this distant shore, the scale of the universe becomes almost overwhelming. The distances are so great that the light we see from Shapley today began its journey when the first multicellular life was appearing on Earth. We are looking back in time to see the structure that is pulling us into the future. This higher order of organization suggests that the cosmic web is not just a static network, but a living, moving system of transport. The filaments are the veins through which the lifeblood of the universe, the galaxies themselves, is pumped toward the great central hearts of matter. Shapley is the greatest of these hearts in our vicinity, a heavy, luminous anchor that provides the ultimate context for our motion through the void. We are travellers on a path that leads from the small to the large, from the local to the universal, following a gravitational command that has been echoing through the dark for 13.8 billion years. The Great Attractor was the first clue. The Shapley supercluster is the revelation of the true scale of the power that governs our flight. The brilliance of the Shapley supercluster and the Great Attractor is merely the visible foam on the crest of a much deeper, darker wave. For every gram of glowing star, shimmering gas, and incandescent dust that we can perceive, there are 5 grams of a substance that refuses to interact with light in any form. This is dark matter, the silent architect of the cosmos and the unseen glue that holds the great architecture of Laniakea together. It does not reflect, absorb, or emit radiation. It is a ghost that possesses weight, a shadow that exerts a relentless pull. Without this invisible scaffolding, the universe as we know it would never have taken shape. In the wake of the Big Bang, the ordinary matter of the universe was too hot and too energetic to clump together. Yet the dark matter remained cool and responsive only to gravity. It began to pool and congregate into a vast, 3-dimensional web of filaments and nodes, long before the first star ever ignited. This invisible framework provided the gravitational seeds into which ordinary gas eventually fell. The filaments of the cosmic web are, in truth, massive ridges of dark matter that stretch across the void like the structural beams of a rising cathedral. The galaxies we see are merely the decorative lights hung upon these beams, tracing the outlines of a much larger and more mysterious structure. The Great Attractor is not simply a collection of galaxies. It is a colossal concentration of dark matter, a gravitational pit so deep that it has been drawing matter into its depths for billions of years. This substance provides the muscle behind the Great Flow, acting as the primary engine that drives the migration of the Milky Way and its neighbours toward the heart of the supercluster. Within the deep wells of gravity created by this invisible substance, a grand symphony of motion unfolds. This is a dance of thousands of island universes, a spectacle of light and destruction that plays out across the eons. As galaxies are drawn into the dense clusters at the centre of the attraction, they are caught in the tidal grip of the dark matter halos that surround them. They do not move in simple, predictable paths, but are swung around in complex overlapping orbits. When 2 galaxies are pulled into a close encounter, the invisible hands of gravity reach out to shred their delicate spiral arms, pulling out long, glowing tails of stars that span hundreds of thousands of light years. These are the tidal bridges, the scars of a gravitational combat that reshapes the very nature of the stars. These collisions are the fundamental mechanism of cosmic evolution. As the dark matter draws galaxies together, their individual identities are lost in a process of mergers and acquisitions. The gas within these systems is compressed by the violence of the encounter, triggering the birth of millions of new suns in a sudden brilliant flash of star formation. The central black holes of these galaxies eventually find one another, spiraling inward in a final cataclysmic embrace that sends ripples through the fabric of spacetime itself. This is the cycle of life and death on a galactic scale, a process of assembly that has transformed the small, irregular fragments of the early universe into the majestic spirals and massive ellipticals we see today. The dark matter provides the stage and the script, while the galaxies are the actors, performing a play of structural growth that has no intermission. The dark matter also acts as the ultimate stabilizer, the invisible glue that prevents the high-speed transit of galaxies from tearing the clusters apart. The Milky Way rushes through the void at 600 kilometers per second, a velocity that should, by all rights, send it flying out into the intergalactic wilderness. Yet, the dark matter within the Laniakea supercluster holds it fast, its gravity acting as an unbreakable leash. It maintains the integrity of the cosmic web, ensuring that even as the universe expands, the local concentrations of matter remain bound together. This substance is the reason the Great Attractor can exist at all. It provides the mass necessary to overcome the thinning effect of cosmic expansion, allowing gravity to win the local battle against the void. In this silent architecture, we find the true meaning of the cosmic web. It is a living, growing entity, a network of dark matter that continues to pull in the surrounding gas and stars. The filaments are the channels through which the lifeblood of the universe is pumped, and the superclusters are the hearts where that matter is processed and reorganized. We are the inhabitants of a world built upon a foundation we cannot see, moving according to the whims of a substance we cannot touch. The spectacle of light we observe in the night sky is merely the glowing residue of a much larger and more profound process of gravitational assembly. The dark matter is the master of the dance, the architect of the heaven, and the silent force that ensures the great flow continues its journey toward the center of everything. Through its influence, the chaos of the primordial universe is ground into the ordered beauty of the superclusters, creating a landscape of light that reflects the hidden strength of the dark. The cosmos is currently locked in a desperate silent tug of war, a conflict between the local gathering power of gravity and the global, relentless expansion of spacetime itself. This is the fundamental tension of our era, a struggle that determines the ultimate fate of every structure within the Laniakea supercluster. On one side of the battlefield stands gravity, the ancient architect that seeks to pull matter together, to forge clusters and filaments, and to draw the Milky Way toward the heart of the Great Attractor. On the other side stands a mysterious and pervasive force known as dark energy, a property of the vacuum that acts as a great disruptor, pushing the very fabric of the universe apart at an accelerating rate. This conflict creates a reality where motion is never simple, and where the destination we chase may forever remain out of reach. Our own velocity of 600 kilometers per second is a measure of this struggle. This speed, which carries us toward the southern sky, is what astronomers call a peculiar velocity, a movement that is peculiar because it deviates from the general expansion of the universe. While the majority of galaxies are being swept away from us by the stretching of space, we and our neighbours are actively fighting that tide, clawing our way toward the central mass of our supercluster. However, the speed of 600 kilometers per second, though vast by any human standard, may not be enough to win the day. The expansion of the universe is not a force that pushes on matter directly. Rather, it is the creation of new space between objects. As we rush toward the Great Attractor, the distance we must travel is being stretched and lengthened by the very medium through which we move. This leads to the profound complexity of the redshift paradox. When we look out at the galaxies that surround us, we see a confusing mixture of signals. In a purely expanding universe, every distant object would show a redshift, its light stretched toward the red as it recedes from us. Yet, because of the great flow, many galaxies show a different signature. Some are moving toward the Great Attractor faster than the expansion can push them away, while others are being overtaken by the stretching of space despite their best efforts to fall inward. We observe a universe where galaxies can be falling toward a central point while simultaneously becoming more distant from that point. It is the celestial equivalent of running toward the back of a lengthening train. Though we move toward the rear door, the door is receding from the station faster than our legs can carry us. Dark energy is the invisible engine of this expansion, a ghostly pressure that fills the void. Unlike matter, which thins out as the universe grows, dark energy appears to be a constant density inherent to space itself. As the universe expands and creates more space, the total amount of dark energy increases, further fueling the acceleration. This creates a feedback loop that threatens to tear the cosmic web apart. In the early stages of the universe, gravity was the dominant force, successfully pulling together the first stars and galaxies. But approximately 5 or 6 billion years ago, the balance shifted. The universe grew large enough that the total influence of dark energy began to outweigh the collective pull of matter. Since then, the expansion has been winning the long-term war, turning the cosmic web into a structure under extreme tension. The Great Attractor and the Shapley supercluster are the last bastions of gravitational order in this accelerating void. Within these massive structures, the density of matter is still high enough for gravity to maintain a local victory. The galaxies within the heart of Laniakea are still bound to one another, their mutual attraction stronger than the repelling force of the vacuum. But on the outskirts of the supercluster, the threads of the web are beginning to fray. Galaxies that were once part of our gravitational family are being pulled across the cosmic horizon, moving away from us so quickly that their light will eventually never reach our eyes again. Dark energy is acting as a cosmic wedge, driving a permanent divorce between the different components of the universe. This disruption has profound implications for the future of the Great Flow. Even as we fall at 600 kilometers per second toward the heart of our immeasurable heaven, the space between the Milky Way and the Norma cluster is expanding. If the acceleration continues at its current pace, a time will come when the expansion of spacetime exceeds the velocity of our fall. At that point, the Great Attractor will begin to recede from us, despite our relentless movement toward it. The cosmic watershed will be broken, its rivers of light severed by the widening gulfs of the void. The very structures that dark matter worked for billions of years to build, the filaments, the clusters, and the superclusters, will be stretched until they snap. We live in a brief, privileged moment of cosmic history, where the two forces are in a state of visible competition. We can still see the Great Attractor, we can still measure our fall toward it, and we can still map the connections that bind us to the rest of Laniakea. But the shadow of dark energy looms over this landscape, a reminder that the order we see is temporary. The great tug of war is a slow-motion catastrophe for the cosmic web, a process that will eventually isolate every bound cluster of galaxies into a lonely island, surrounded by an infinite and unreachable darkness. Our journey toward the center is a race against the growing void, a flight toward a destination that the universe itself is trying to push into the eternal distance. In this struggle, our velocity of 600 kilometers per second is our only defense against the coming isolation, a desperate surge toward the light before the dark energy claims the horizon. Beyond the influence of the Shapley supercluster, at the very edge of what can be perceived by human instruments, a deeper and more controversial mystery haunts the data of the cosmic microwave background. This is the dark flow, a signature of motion so vast and so coherent that it threatens to overturn our most fundamental assumptions about the structure of the cosmos. While the Great Flow describes the organized migration of galaxies toward the heart of Laniakea, the dark flow suggests a far more unsettling reality. A significant portion of the observable universe appears to be rushing toward a point far beyond our horizon. This is not a local drift or a response to a visible titan, but a uniform, high-speed transit of hundreds of galaxy clusters, all moving in a singular direction toward a patch of sky between the constellations of Centaurus and Vela. The observable universe is a sphere of light, its radius defined by the distance that photons have been able to travel since the beginning of time, 13.8 billion years ago. This light horizon is a hard physical boundary, a wall of time beyond which we cannot see, no matter how powerful our telescopes become. Because the universe has been expanding since its birth, this sphere now spans approximately 46 billion light-years in every direction. To the conventional scientific mind, this volume of space should be self-contained in its gravitational behavior. The matter within this sphere should only be influenced by other matter within the same sphere, as the speed of gravity is limited to the speed of light. Yet, the dark flow implies that something gargantuan and unseen, existing outside this 46 billion light-year boundary, is reaching across the horizon to pull upon the matter inside. The evidence for this motion emerged from the meticulous study of the hot gas within distant galaxy clusters. By observing how the ancient light of the Big Bang is scattered as it passes through these clusters, a phenomenon known as the kinematic Sunyaev-Zeldovich effect, astronomers detected a consistent velocity that cannot be explained by any known mass within our horizon. These clusters, some of them billions of light-years away, are moving at speeds of nearly 1,000 kilometers per second in a direction that does not align with the Great Attractor or the Shapley supercluster. It is as if a fleet of thousands of ships scattered across a vast ocean were all suddenly caught in a single massive current that ignores the local winds and tides, carrying them all toward a destination that is hidden beneath the curve of the world. The implications of such a flow are staggering. If this motion is real, it suggests that our observable universe is not a representative sample of the whole, but merely a tiny, insignificant bubble within a much larger and more complex landscape. It hints at a reality where matter is distributed in ways that defy the principle of cosmic uniformity. Somewhere, far beyond the reach of our light, there may exist concentrations of matter so immense that they dwarf superclusters like Laniakea, structures of such gravitational potency that they can dictate the movement of everything within our field of view. This would mean that the Big Bang was not a uniform explosion, but a messy and uneven event that left behind a cosmic texture of unimaginable scale. This theory remains a subject of intense debate within the halls of academia. Many scientists argue that the signal of the dark flow is a statistical ghost, a product of the extreme difficulty of measuring such subtle motions across such vast distances. They suggest that as our data becomes more refined, the anomalous flow will vanish, leaving behind a universe that is once again predictable and self-contained. Yet, for those who find the evidence compelling, the dark flow is a window into the pre-inflationary era. It may be an echo of the very first moments of existence when the universe was smaller than an atom, and the seeds of these massive distant structures were first sown. In this view, the motion we see today is a lingering memory of a connection that was established before the universe underwent its period of rapid exponential growth. If we are indeed caught in the grip of an influence from beyond the horizon, it changes the very nature of our quest for knowledge. It means that we are like inhabitants of a small island who have mapped every tree and stone, only to realize that the entire island is being towed across the sea by a giant whose form we will never see. The boundaries of the observable universe are not the boundaries of reality, but merely the limits of our perspective. We are part of a larger machinery, a vast and ancient system of motion that extends into a darkness we are forbidden to enter. The dark flow represents the ultimate unknown, a reminder that for all our progress in mapping the immeasurable heaven, we are still voyagers on a very small ship in an ocean that may have no end. This realization brings a sense of profound mystery to the study of the Great Attractor and Laniakea. We are not just falling toward a local center. We may be part of a much larger cascade of matter, a grand migration that spans the entire canvas of existence. The forces that govern our flight are not limited to the stars we can count or the clusters we can name. We are moving in response to a cosmic architecture that was built on scales we can barely conceive, guided by masters that reside in the eternal night beyond the light. As we continue our journey through the obsidian void, we must accept that the most important part of the story may be the part we are destined never to see. A silent command from the deep that carries us toward a destination beyond time and space. Trillions of years into the future, the cosmic landscape has undergone a transformation that renders it unrecognizable to the eyes of the present. The era of the stars, those brilliant lanterns of the deep, has entered its long, slow twilight. The vibrant blues and fierce whites of young suns have vanished, replaced by the weary, cooling embers of red dwarfs and the crystalline husks of white dwarfs. In this profound darkness, the great flow reaches its ultimate conclusion. The Milky Way and its ancient companion Andromeda have long since merged into a single, massive elliptical entity, a bloated ghost of the former spirals. This singular galaxy, containing the combined remnants of our local neighborhood, finally completes its multi-billion-year descent into the heart of the Great Attractor. The final approach is not a violent collision, but a majestic slow-motion convergence of giants. The local group arrives at the central node of the Laniakea supercluster, joining the thousands of other galaxies that have already been funneled into this gravitational pit. The Norma cluster, the Centaurus cluster, and the remnants of our own neighborhood begin a process of titanic integration. In this cold, dark future, the gravity of the Great Attractor has won its local battle. The dark matter scaffolding, which has stood for eons, finally draws the baryonic matter into a single colossal conglomerate, a superstructure of stars and black holes that spans millions of light years. This is the Great Merger, the moment when the rivers of the celestial watershed finally meet in a central stagnant sea of matter. As this local union is finalized, the rest of the universe has become an unreachable memory. The Great Divorce, driven by the relentless expansion of dark energy, has reached its logical extreme. Every other supercluster that was once visible in our sky, the Perseus Pisces, the Coma, and even the mighty Shapley supercluster, has been pushed beyond the cosmic horizon. The space between these structures has expanded so rapidly that light can no longer bridge the gap. Our merged supergalaxy now sits in an infinite empty void, a lonely island of light in a universe that has grown cold and silent. The cosmic web has been torn asunder, its filaments stretched until they snapped, leaving Laniakea as the only thing that exists within our observable reality. The great flow has ceased because there is nowhere left for the matter to go. The watershed has been drained, and the surrounding territory has been lost to the accelerating vacuum. Within this island of remnants, the motion that once defined our existence begins to fade. The internal orbits of the stars within the merged cluster settle into a state of frozen equilibrium. The heat of the Big Bang has been dissipated into the infinite dark, and the entropy of the system reaches its peak. This is the death of the current, a state of cosmic stillness where the gravitational titan has consumed everything within its reach, and now has nothing left to pull. The Great Attractor, once a symbol of dynamic motion and hidden power, becomes a silent tomb for the galaxies it once commanded. We are left with the ghost of a destination, a place we spent trillions of years chasing, only to find that it is the last stop on a journey into the eternal night. Yet, as we look back from this distant, desolate future to our own time, the significance of our journey is revealed. We return to the image of a tiny, fragile planet, circling a modest yellow star in the suburban reaches of a vibrant Milky Way. From the deck of this drifting ship, a species of brief existence and limited reach managed to do the impossible. They mapped the currents of the cosmic ocean. Without ever leaving their home, they used the laws of physics and the light of distant fires to perceive the invisible hand of the Great Attractor and the immeasurable heaven of Laniakea. They looked through the Great Wall of Soot. They measured the velocity of their own fall, and they understood the tug of war that would eventually tear their world apart. The human spirit, caught in a fleeting moment between the birth of the stars and the coming of the dark, found purpose in the act of seeking. The Great Attractor was never just a coordinate in the sky, or a concentration of mass. It was a symbol of the unknown that calls to every voyager. The realization that we are part of a grand, ancient migration gave our brief lives a sense of cosmic belonging. We discovered that we were not just drifting aimlessly through a void, but were participants in a magnificent structured dance of light and gravity. Every star we saw was a fellow traveller, and every galaxy was a companion in the great silent fall toward the centre of everything. Even if the destination is a graveyard and the journey ends in isolation, the act of mapping the current remains our greatest achievement. It is a testament to the power of the mind to transcend the limits of the body and the constraints of time. We are voyagers who have understood the sea, even as we are swept away by its tides. The Great Attractor is the heart of our story, a reminder that we are part of something vast, ancient, and profoundly beautiful. As the last embers of the stars fade and the universe prepares for its final, cold sleep, the memory of our seeking remains, a flickering candle in the dark, a sign that for one brief, glorious moment, the water in the river knew it was moving toward the sea. We are the seekers of Laniakea, the children of the great flow, and our voyage into the heart of the mystery is the ultimate expression of our place in the immeasurable heaven.